Let's go to page 131. Today's lesson is on the hyperbolas. So if you go to page 131, the definition 3.4, it says a hyperbola is a set of points in a plane such that the difference of the distances of each point of the sets from two fixed points, foci, in the plane is constant. So this is like it's similar to the ellipse. So you got 2 points, you got F and another focus over here. And if so, any point, so this point P, so any point that on the on the hyperbola, you get D1 and this is D2. So any point on a hyperbola will have D1 minus D2 equal to a fixed number, a constant. In this case, again, it's 2a. So the difference of the distance will equal to 2a. Now, easy way to understand the hyperbola is think of it as the ellipse turned inside out. So remember, in ellipse is a plus, right? And the hyperbola is a minus. And again, you have a different parts for the hyperbola. Now again, for the hyperbola, just using an example. So again, I'm going to draw the hyperbola first, and I will explain. So whenever you have hyperbola, it's easier if you draw the box, and again I will explain what this is. Okay. And after you have rectangular box, you draw the asymptotes. Okay, the dashed line. Those are like your boundaries, your limits. So this dashed line is called asymptote. Now for this one, it depends on the direction. So what you have over here, so you need to know all the parts. Okay. So first, again, you need to determine the direction of the graph. You can go in the x direction or you can go y direction. So let's go and just, for example, let's say it go in the x direction. So if the graph go in the x direction, so when you sketch out the graph, okay, make sure it approaches the asymptote, the dashed line, but it will never touch. Okay, the graph will never touch the asymptote. Okay. So this is the center over here. This point is the center. This is the vertex, V, and you're going to have a point over here, and this will be the focus. So this is the V, and this will be the focus. Again, this point over here is the B, and this is the B. Okay. So before, when you have ellipse, your ellipse would be on the inside, right? But now you have a hyperbola, the graph is like turned inside out. So again, think of ellipse got turned inside out. Okay. Now when you have ellipse, the F is over here, but now when you get flipped, it got turned inside out, the F is out here now. Okay. And the distance you have, so that's A. Again, just like before. This is B. Okay, now the C, because it got turned inside out, the C is your biggest number now. So this is your C. So in this case, that's your C. So if you were turn this way, then this would be the C, or if you move this way, this would be also the C. So you can see in this case it's a diagonal. So if you were to draw this, if you draw this triangle over here, then this would be the C, okay, which is also this distance over here from the center to F. From the center to F is always the C. From center to V is always the A. From the center to B is always the B. Okay, so it's always. Okay. Now if you notice, this is a rectangle over here. So the C is this distance over here, which is a hypotenuse. Or if you do it the other way, if you draw your triangle, if you slide this over, this is also the B over here. Right? And if you slide this over, this is the A over here. So in this case, this would be your C. Right? That's your hypotenuse. So this is your regular, the one you're more familiar with, right? So in this case, you have the A squared plus B squared equal to C squared, the Pythagorean Theorem. Okay. Now there's a name for this. Okay. Again, this is your 2A. This is your 2B. So the one that go from V to V, so from V to V, it's equal to 2A. And there's a name for it. This is called the transverse axis. So from V to V, so this is on page 132. So from V to V, from vertex to vertex, that's your 2A. And this is called a transverse axis. Now from B to B is equal to 2B. Right, that's this over here. And that is called a conjugate axis. So again, this is the transverse axis. This is the conjugate axis. Okay. Now, also just like the ellipse before, if your graph is going this way, and if you go from here, go straight up and down, again, this distance is B squared over A. Just like the ellipse. Like I say, hyperbola, best way to understand is think of it as ellipse got turned inside out. Okay. And so in this case, this length is the lattice rectum, right? So L equal to 2B squared over A, right? This entire length. So this is when you go in it. So your equation would be, since this going in the x direction, so if you go in the x direction, the x will comes first. And the center is your h and k, right? Okay. So this is going in the x direction, so x will come first. And if x comes first, the y comes next, right? Okay, so this is when you're going this direction. It's going the x direction. Now, if it's going the y direction, then y will come first. Okay. So for the hyperbola, whichever comes first, the one that was positive determines the direction. And notice in the hyperbola, the a square always comes first. Okay, a square is always go whatever direction is. So if x comes first, then the a will in the x direction. If it go in the y direction, the a will be under the y. So notice in the hyperbola, the x and the y get switched. Okay. Whereas if you compare that with the ellipse, okay, if you compare that with ellipse over here, if you compare that with the ellipse, so this is the ellipse, so ellipse is plus, hyperbola is minus. Okay, and for ellipse, right? You always both are positive, so you always keep the x first, and then you switch the a and the a square and the b square. Okay, I think this is quite easier to remember. Okay, but if you want to memorize it this way, that's fine too. Okay, so again, just make sure that you know all the relationship. Okay, and again, just same thing with ellipse. Okay, whenever you deal with hyperbola, again, first you want to get the direction. Figure out the direction that it's going, whether it is in the x direction or the y direction. And after that, you get your center. Again, that's your starting point. So everything starts on the center. Okay. Then after that, you get the ABCs. And then for hyperbola, you draw the box. So draw this box over here, or the rectangle. Okay. Then after that, you draw asymptotes. Then after that, you can do whatever what else you need to do. Whether plot the focus, or label the focus, label the V, label the B. Okay, whatever they need to do, you do after that. But you get these things done, and it will help you to able to figure out the rest of the stuff.